Hello, am I audible? अभी आवाज क्लियर है सबको? ओके, सॉरी एवरीवन, मैंने पहले नहीं देखा। हम स्टार्टिंग से स्टार्ट करते हैं। मैं एज्यूम कर रहा हूँ कि स्टार्टिंग से ही वॉइस ख़राब हो गई थी, तो ओके। सो in last class, we looked at very basic stuff required in programming. We first looked at number system conversion and then we went to operators. In this class, we will go through the basic stuff very quickly so that we can start the actual coding stuff as soon as we can, right? So we have here a very basic C program. Okay, so we have a very basic C program, and we will decode what is written here. So when you will write your first C program, a very basic C program, it will look something like this, right? So on the first line, I have written this hash include stdio.h. This .h is a header file which contains the declaration of some of the terms or keywords which we have used in our code, right? So for example, when we will compile our program, our compiler will not know what is printf, right? So we have to tell the compiler that, okay, if you want to know what is printf, its declaration is written inside this file stdio.h. That's why we have included this file hash include stdio.h, right? So it contains the declaration of many keywords which we use in our C program. Next, we have this main function. Okay, so in main function, if you have like seen programs of any other programming language, you must have seen that we write this main function almost in every programming language, right? But why do we do so? Your software is made up of multiple modules. Okay, your software is made up of multiple modules. In a Windows, the extension for a software is .exe file, right? When you run this .exe file, the modules behind this software start getting executed. Okay, so but how will we know which module will run first? A software can have hundreds or thousands of modules behind it. So when we double click on our .exe file, how will we know, or how will the system know that a particular module needs to be run first? It will look for a main function. Okay, so our operating system executes the program or a software, and it looks for a main function. So this main function is for our operating system. This is the entry point of our code. So if you have hundreds or thousands of files, only one file will have a main function, right? Only one file can have a main function, and that main function will start executing first. So this is the main function. After that, I have written printf and then hello world. In double inverted comma, I have written hello world. Whatever we write in this double inverted comma, it will get printed on the console directly, right? At the end I have written return 0. Okay, so why I have written return 0? Because with this main I have written int. That means a data type of int will be returned from the function. We will look at the functions in the later classes. Just understand that this main is a function and this is the return type of the function, and that's why we have returned 0. Also, in programming languages, 0 is considered as an successful execution. If you run a file and you get 0, exit status 0, that means your program ran successfully. If the exit status was other than 0, that means your program couldn't run successfully. So this is the purpose of return 0. So this is a very basic program, int main, and I have written just a print statement and return 0. Okay, now we move to data types. In case in the real world we are all dealing with data, we are storing the data, we are accessing the data. So in the programming we must learn what are different types of data types. So in C programming we have two different types. One is primitive data type and the other one is user defined data type. Primitive data type are int, char, float and double. Okay, so if you want to store an integer value, you can use int. For a character you can use char. For a float, which means a number with decimal or point, you can use float, or a number with more precision you can use double. So for example, in float you can store 4.2, but suppose you want to store more precise value, 21653, you can use double. Below these data types I have written their size. Okay, so if you store an integer value, it will take 4 bytes. If you store a character value, it will take 1 byte. If you store a float value, it will take 4 bytes. And if you take a double value, store a double value, it will take 8 bytes of memory. And you can figure out the size of any variable using this size of operator. So in C language, we have a size of operator, and if you use it, it will tell you the size of any variable. In user defined data types, we have structure, union, enum and typedef. And as the name suggests, this is a user defined. That means a user will define according to their need. So this is for later part, but you should know the basic or primitive data types for now. So structure, union, enum and typedef, you can understand them later when we have covered all the basic topics. Okay, so this is a basic C program and these are the data types. Next, let's come to the topic of format specifier. Whenever you are using a particular data, you are either printing it or you are taking it from the user, whatever it is, you need to specify its format. Okay, you need to tell the compiler, okay, I am handling this particular type of data. For that, you use format specifier. Okay, so for int, we have a format specifier %d. For char, we have a format specifier %c. For float, we have %f, and for double, we have %lf. Okay, so I have written the example here how we use the format specifiers. But format specifier means you need to specify the format to the compiler that okay, I am handling this particular type of data. So if you are using %d, it means you are handling a data of type integer. If you are using %c, it means you are handling a data of type char. Okay. Next, we come to variables. So we can define a variable in very simple word. It is a named storage. Okay. So you name a storage space and that is a variable. Okay. So how do we declare a variable? So we write, first we write the data type, then we write the name of the variable, then we can assign any value to it. So int num equals to 7, right? Or if we want to make a char variable, so we can write char, which is the data type, temp, which is the name of the variable, and a value. So anything which is written in single quotes, anything which is written in single quotes is a character. Okay, so if I write 2, it is an integer right now, but if I enclose it in single quotes, it is a character. Okay, so anything which is written inside a single quote, it is a character, and you cannot write more than one digit or one character in a single quote. So you cannot write like this. This will be wrong. Okay, a single character can be there in a single quote. Okay, so this is how you declare a variable. Next, when you want to print something on console, we have seen the printf in the previous slide. So here I'm using first the format specifier. Now, as I said, when I'm printing a variable, I need to tell the compiler what kind of variable it is. So with this %d, the compiler will be able to see that, okay, this is a %d, that means the variable I'm printing is an integer variable. Okay, so this is how you use format specifier. So in double inverted comma, you use format specifiers, then comma, and then your name of the variable. Notice that I said earlier, whatever you write in double inverted comma will get printed exactly, but the format specifier will not get printed. Okay, the format specifier will not get printed, only the value inside num will get printed. Okay, so this is how you print something on the console. Next, taking input from the user. So it is a known fact that you don't have all the data while you are programming, right? While you are writing the program, you don't have all the data. You are writing program for someone, you are writing program for a user. So that means user should be able to input their own data. And if you want to take input from user, we use scanf in C language. Okay, so if I want to take value inside a variable named num, what I'll do, I'll again use a format specifier. I'll tell the compiler I want to take the input in an integer variable. Then I will use this operator. This is the address of operator. Okay, we call it address of, and the name of the variable in which I want to take the input. So first the format specifier, the address of operator, and the name of the variable. This is how you take input from a user. In upcoming classes, we will directly write these code on VS Code so that you can understand it better. But for now, let's understand theoretically on board. Because in many interviews, I am telling you that in many interviews, you will not be allowed to use any IDE. Okay, you will not be allowed to use any online compiler. In many companies, they want you to write the code on a plain Word document or a notepad. So it should be your habit to write the code without any help from IDE or your compiler or any online compiler, right? So, but we will look at these codes in the later classes, right? So this is how you print on console and take the input from the user. Next. Now, in the last class, I already discussed all the operators, but conditional operator was left, and I told that we will look at in the next class. And today, let's check how we can use if else. So here I have different cases. I can see here how we use if and else. So if is something which allows you to run a code based on certain condition. What happens is when you write a code, every single line will be a part of your exe or executable file from top to bottom. But suppose you want to run a certain piece of code, you want to run certain lines only if a condition is true or it is false. right? In that case, you use if and else. Let's look at an example. So when you write if, what you do, if in parentheses you write a condition, okay, and inside the curly braces you write some code. You can write any code you want. Okay, if this condition is true, only then this code will get executed, otherwise it will be skipped. So for example, if I write if 7 is greater than 9, now as I told you, this is a relational operator, and relational operator gives something in terms of true or false. So if 7 is greater than 9, 7 is greater than 9 is a false statement, right? It is a false condition. 7 is not greater than 9. Since this is false, this particular statement will not run. Okay, this particular statement will not run. This will get skipped and we will move ahead. Okay, so this is how a single if works. You can write a simple if, write any condition, a statement. If the condition is true, the statement will get executed. If the condition is false, we will skip it. Second part, you can combine else along with if, right? So I have written if, again the condition which is similar to what we have seen here, and now I have written else. If you notice carefully, I don't have any condition with else, right? I don't have any condition written here with else. So what will happen, we will come from top and we will check this condition. If this condition is true, then this code will get executed, and then we will come directly here skipping this else part. We will skip this else part if this condition is true. Okay, if this is true, we will run the code and we will come here. But if this condition is false, that means we will skip this code and we will directly run the code written in else, because we don't have any condition. So we will not check anything. If this is false, then we directly run this code and then we come down. So this is if and else. Note that we can write if without else, right? If even if we don't write else, we can still use a simple if. But if we can't write a single else without if, okay? So if we write just else part and if we don't write anything here above, then we will get an error. Okay. Now come to next case. We have if, and this time we have else if. So suppose you want to check multiple conditions. What is happening right now is we have checked one condition, and if that is true, we will run this code. If this is false, we will run this code. But what if we want to check multiple conditions? Okay. In that case, we will use else if. So if condition 1, then this code, else if condition 2, then this code. So what will happen? I will come from the top. If condition 1 is true, we will execute this code and we will skip all of these. We will not run all of these if this condition is true. Okay, so if this is true, we will run this code and we will skip this code. But if this condition 1 is false, if this condition 1 is false, we will check the code in condition 2. Okay, so we will check if condition 2 is true. If it is true, then we will run this code and we will skip all of these. Okay, we will skip all of these and we will run this code. But if this is false, then we will check this condition. If this is false, then we have else at the end, which doesn't have any condition. So we will directly execute this particular code, right? So there are multiple conditions which we can check with the help of else if, and we can use as many else if we want, 2, 3, 5, 10, 20, as many else if you want, depends upon how many conditions you want to check, right? So this is the simple if else and if else if else, right? Let's move ahead. We have another operator which can check conditions, and if we have very small statements to execute, we can use this operator. So this is a ternary operator. Ternary means it will have three operands. Okay, it will have three operands, and this is how we use this operator. First we write a condition. After that condition we use a question mark symbol. Then we write our statement 1, or we can say code 1. Then we use this colon symbol and statement 2. So I have written an example below. Suppose I have a variable int m equals to 9, int n equals to 14. Okay, two variables, m is 9, n is 14. And here I have written a condition, m is greater than n. So it will check the condition if it is true or not. So if the condition is true, always the statement before the colon will be executed. Okay, if the condition is true, always the statement before the colon will be executed. And if the condition is false, always the statement after the colon will be executed. Okay, so condition is true, statement 1, condition is false, statement 2. Okay, so if m is greater than n, if this condition is true, this will run. If this condition is false, this will run. Okay, so m is greater than n, m is 9, n is 14. So 9 greater than 14. This condition is false, and since this is false, it will go to the statement after the colon and it will print n is larger. Okay, so condition, code 1, code 2. If the condition is true, code 1 will run. If the condition is false, code 2 will run always. So this is helpful when you have very small statements to execute, because generally this comes in one line. Okay, so you can use ternary operator when you have very small conditions to check or small statements to execute. So this can also check the conditions and execute the statements for you, right? Next, let's come to loops. Okay, so when do we use loops? Suppose you want to print numbers from 1 to 100. Okay, now if you do it the usual way, like we print single or two numbers, you will have to write either 100 printf statements, or you will have to write manually 1 to 100 on your own in your program, right? So you are doing a repetitive task one by one manually. To avoid that, in programming we have loops. Okay, so when you have to do repetitive tasks, when you have to repeat something multiple times, you can use loops. A loop, to write a successful loop, you need to have three things. First, initialization, next, condition, and next, variable update. Okay, so to write a successful loop, you need to focus on initialization, condition, and variable update. These three things are the components of a loop. So let's look at an example. In C language, we have three types of loops: while loop, for loop, and do while loop. Okay, let's look at while loop first. In case of while loop, before while loop we do the initialization. Okay, we will see the example. We do the initialization, then in while parenthesis we write condition. Okay, we write condition, then we write some code which we want to run again and again, and before ending the loop, before ending the while loop, we do the variable update. Okay, so initialization before while loop, condition in the parenthesis, and before ending the loop we do variable update. Example, suppose I need to print the numbers from 1 to 5 for now. Here is the initialization, where I am initializing a variable I, because I want to start from 1, I am initializing it to 1. Next, we have while loop. Inside while loop, I have a condition, I less than equals to 5. After this condition, I have written a piece of code which I want to run again and again. and here is the variable update I plus plus. Okay, so what will happen if I skip this step? If I don't do I plus plus, that means my I will never change. My I, if my I will never change, then this condition will never be false, and we will run into an infinite loop. So this is required to modify the condition. Okay, so if we skip the variable update, our loop can go into infinite loop. Okay, so this is I equals to 1. So what happens is we initialize, we check the condition I less than equals to 5. I is 1, 1 less than equals to 5, which is true. That means we will print 1, we will increment I by 1, it will become 2, and then we will again go to this condition to check. If now 2 is less than equals to 5, it is true, we will again go into the loop, print our variable and do I plus plus, and so on. So this is how our while loop will work. Okay, now let's move to for loop. For loop has these three components, again same, but we can write them on a single line. So we have initialization, then we have a semicolon, we have condition, then we have a semicolon, and then we have a variable update. Okay, and inside we can write the code. So this same code can be written like this using for loop. So here I have the initialization, here I have the condition, and this is the variable update, and this is the code. Okay, so what happens is this line runs first, I equals to 1, then we check the condition. If the condition is true, we run our code, then the variable is updated, then we again check the condition, then we again execute the statement, then we again update the variable, then we again check the condition, and so on. So this is our while loop and this is our for loop. Performance wise, you won't find any difference between the loops. Okay, so students usually ask which loop is the best and which loop should be used in certain scenarios. You can use any loop you want and you are comfortable with. If you feel more comfortable with for loop, use for loop. If you are more comfortable with while loop, use while loop. It doesn't matter. Okay, next we have one more kind of loop, which is do while loop. Let's look at it. It is a little bit different syntax wise, and but it works the same way. First, before do while, we do the initialization before do. After do, we start this curly braces. We write our code, and before we end our curly brace, we do variable update. Then we write while and then condition. Okay, initialization, variable update, and condition. Three things. Now we can see the example here. I have done the initialization here, int I equals to 1, do, then our code, then variable update and condition. Now notice what is different in this loop is we don't have any condition initially. In previous loops, if you see when we come from top, we had the condition before loop started. We had the condition before loop started. But in case of do while loop, our loop has started from this point, but our condition is below here. This is the difference. And how it is different? Because when we come from top, we will initialize the variable and we will directly enter the loop without checking any condition. Okay, we will enter the loop without checking any condition because we don't have any condition here. We have condition at the bottom. So we will directly enter inside the loop. So we will execute this statement. It will print 1. We will do I plus plus, that means I was 1, but after this statement it will become 2, and then we will check the condition. Now if the condition is true, we go again to the first statement, and again print. Then we do I plus plus. We check the condition. If it is true, we again go to first statement and so on. So the difference in do while loop is that it executes at least once. It will get executed at least once even if the condition is not true, right? Even if the condition is false, we are coming from top, and since there is no condition here, we will execute the loop once. And then only we will check the condition and we will decide if we want to execute again or not. So this is your do while loop. Okay. Now let's understand the concept of nested loops. Okay. In nested loops, we write a loop inside a loop. Okay. So for example, okay, so what I have done here is, this is my for loop. It starts here, ends here. Inside this for loop, I have this while loop which starts here and ends here. Okay, so I have written a loop inside a loop. This is an example of nested loop. Let's quickly try to figure out how this runs, how it works. So first, what I have done is I have a variable I, which is starting with 1. Okay, we will check the condition. If I is less than equals to 2, which is true, so we will come inside the loop and we will create j equals to 0. Okay, j equals to 0. Now we will check the condition. If j is less than equals to 1, since j is 0, this condition is true. 0 is less than equals to 1. So we will print j. So we will print whatever it is inside in j. So j is 0. Now we do j plus plus, which means j is incremented to 1. Now we again check the condition. Like I said, once we do variable update, we again check the condition. So 1 is less than or equal to 1. It is still true because 1 is equals to 1. That means we will print j, and now j will become 2. When j becomes 2, we go to this condition, and now 2 is less than or equals to 1. 2 is less than equals to 1, which is false. That means we will come out of this loop. And since all the statements of this for loop are executed, we will increment our variable to 2. Okay. Now we will start again. So a new j will be created again because I'm creating a j every time. So j will again start from 0. Our previous output will be there. It will not get deleted. So while again it will check j less than equals to 1, condition is true, 0 will be printed. J plus plus 1, again this condition will be checked, 1 less than equals to 1, j will be printed. Then j plus plus, again condition will be checked. Since now 2 is not less than equals to 1, it will come out of the loop and all the statements are executed, so our I will become 3 now. So initial we had 0 1, now we have 0 1 again. And now when we will check the condition 3 less than equals to 2, it will be false. So we will come outside of this loop. So this is how nested loop works. I might have gone very fast in this, but when the recording comes, if you see, I have written every step what is happening at each line, so you will be able to easily understand after that. Okay, so this is what nested loops are. Sorry. So now, based on the nested loops, we come to a very important topic and usually asked in college interviews to check your logic without any heavy data structures. So if someone wants to check your logic building skills without any heavy data structures, they can use the next topic which I am going to teach you. So that topic is pattern printing. Okay, this is a very common topic which everyone has studied in their first semester when they have studied C, or if you are in already in your first or second semester, you might be currently studying this pattern printing. Pattern printing is the kind of topic which, although based on only the loops, but it can definitely check your logic building skills, and it helps the interviewer to assess your knowledge. And this is the type of question which has infinite number of possibilities. Like we can interviewer can give any type of pattern. Okay, so there is no limit. But the thing is, many students try to cram the code usually taught in college. Like if I write like this code will be printed. If I use this condition, this code will be printed. But what happens is, if someone gives them a new pattern, they get stuck. So what we will do, uh, not sure we have much time today to complete this topic, but at least we are starting with this so that you have the idea before we start the next class. So what we will do, we will actually look what happens behind the scene. We will print each and every character and where it will get printed, so that you can build the logic on your own when you are trying it. And I would advise you to practice these types of question on pen and paper first, and then write code on your system. Okay, so while printing a pattern a pattern has two dimensions. It has rows and it has columns. Okay, so a pattern has two dimensions, rows and columns. And if we are able to figure out the number of rows, number of columns in each row, then we will be able to write the code very easily, right? We will be able to find the logic, and we will be able to actually see why we are writing some condition and how it is working. Okay, so when we approach these kinds of question, we first figure out number of rows. Okay, any pattern you get, you will first figure out number of rows, and the steps I am telling you will work for any kind of pattern. Okay, next you will figure out number of columns in each row. Okay, rows and columns. And third will be what to print. Okay, are we printing stars, are we printing cross, are we printing numbers, alphabets, what are we going to print? So these three steps are there: number of rows, number of columns in each row, and what to print. Okay, so if we understand these steps, if we are able to figure out these things, the pattern printing questions will get 90% easier for us. Okay, it will get 90% easier for us. So I will take a very basic pattern today, very basic, very simple and very basic pattern. From the next class, we will see what different kind of pattern is possible, right? Their variations will be infinite, but some of the things are always same. So in this session, I will take a very basic question. Again, I am saying very basic. So suppose I need to print this pattern. Okay, this is a very simple, this is the simplest pattern you can see. And for many of you, I know that many of you can code this pattern. It's not an issue, but I need to start with a very basic pattern, okay, because we will go step by step so that you can understand what is changing at each pattern. Okay, so that's why I'm taking a very simple pattern. So I guess you must have seen these steps, so I will erase them. Okay, as I said, first we will figure out what are the number of rows. 1, 2, 3, 4. Simple. We have 4 number of rows. Okay, and we are going to use nested loops for these types of questions. So first we figured out what are the number of rows. So first loop will be for number of rows only. We need to print 4 rows. So I need to write a loop which can run 4 times. It's simple as that. That means I can start I with 1. It will go till 4 and I plus plus. So 1 from 1 to 4, 1, 2, 3, 4. It will run 4 times. Okay, I could have started from 0. In that case, I would have changed my condition to this. So both are fine. Previous one will also run 4 times. This one will also run 4 times. Okay, so the purpose is to have 4 rows. So the loop will run 4 times. It's very simple, right? So the first loop will always be for row, and the inside loop will be for columns. Okay, the inside loop will be for columns. That means let's first figure out how many columns are there in each row. In first row, we have 1, 2, 1, 2, 3, 4. 4 columns. In second row, we have 1, 2, 3, 4. 4 columns. Third row, 1, 2, 3, 4. Fourth row, 1, 2, 3, 4. In every row, we have 4 columns. That means the loop for columns will be similar to what we have written for our row. So I can write if you notice, everything is same, only the variable is changed from 0 to 4. So now what we actually want to print, which was our third step, whatever we want to print will be written inside this column loop. Okay, whatever we want to print will be written inside this column loop. So we want to print simple cross and this is how we can print it. Okay, still one thing is left. Okay, this is not the complete code, the one thing is still left. What will happen now, when we print it 4 times, our code doesn't know when it needs to change the line, for that we have to tell it. So what we want is, when the loop has run 4 times, the column loop has completed once, we can change the line. To change the line, we can use this /n inside printf. This This is called an escape sequence, and its functionality is to change the line. Okay, so this is a new line character. As soon as I write this, the compiler will know that it needs to switch the line. So what will happen? For I equals to 0, my this loop will run from 0 to 4, and it will print this x 4 times, 1, 2, 3, 4. After that, I will change the line. That means I will come here. Then for I equals to 1, because earlier it was 0, now it will become 1. This loop will again run 4 times from 0 to 4. That means 1, 2, 3, 4. And again, after this loop, I'll change the line. So this is how the pattern will be printed. If you can figure out the number of rows, the number of columns in each row, the question becomes very easier, and we will see different types of patterns as well. As I said, this is a very basic pattern. It will not be asked in the interview. But since we are starting and I'm showing the code for this pattern first time in this class, so I had to choose this simple pattern. But in the next class, we will look at more variable types of patterns, right? So this is your pattern printing question, and this is how you write the code for it. Okay. In the next class, we will continue with this topic, pattern printing, and I guess the next class will be dedicated to pattern printing only, because we need to see different types of patterns, and we need to figure out how we actually choose the condition, how we start the variable. So that those things will be covered in the next class only. Okay, so you can watch the video again to revise the topics. You can practice writing simpler loops if else, and we will meet in the next class.